In math, it feels like we've got a tool for just about everything, right? But what happens when the number you're trying to find is stuck up there, as the exponent? Well, today, we're going to solve that exact mystery.
All right, let's kick things off with a problem where our usual bag of tricks, addition, division, they can't crack it.
So check this out. On the left side, these are pretty straightforward, right? A little division, maybe a square root, and boom, you've solved for x. But now, look at the equation on the right. Our poor little x is trapped. It's stuck way up in the exponent spot, and there's just no simple everyday operation that can get it down from there. That's the challenge we're facing.
I mean, we can kind of ballpark it, right? We know that 2 to the 4th power is 16 and 2 to the 5th is 32. So logically, x has to be some number between 4 and 5. But come on, in math and science, somewhere in the middle just doesn't cut it. We need the exact number. So the big question is, how on earth do we find it?
To solve this puzzle, to finally free that trapped exponent, we need a special key. A really powerful tool that was literally designed for this one specific job. It's time, my friends, to meet the logarithm.
Think about it like this. Addition has an opposite, right? Subtraction. Multiplication has its opposite, division. They undo each other. Well, to undo an exponent and get that variable all by itself, you need a special operation, one that was tailor-made for the job. And that operation, you guessed it, is the logarithm. Now, don't let the name scare you off. It sounds complicated, but at its heart, a logarithm isn't some crazy calculation. It's actually just asking a really simple question, a question that we've turned into a powerful math tool.
Okay, so this is what it looks like when we write it down. You've got b, that's our base, the number that's being raised to a power. Then there's a, the argument, which is the final number we're trying to hit. And x, well, x is the star of the show. It's the answer we've been looking for, the exponent.
And here's a little secret to help you remember how it all connects. It's called the circle trick, and it's awesome. You start at the base, b, you swing all the way around to the other side of the equation to the exponent, x, and then you end up back at the argument, a. What does that give you? b to the power of x equals a. See? This just shows that saying log base b of a equals x is really just a fancy way of saying b to the x power equals a. They're the exact same thing, just dressed up differently.
All right, theory is great and all, but the best way to really get the hang of logarithms is to just do it. Let's see them in action. We're going to run through a few quick-fire examples.
First up, what's log base 5 of 25? Don't overthink it, just ask yourself that simple question. 5 to what power gets me 25?
Yep, it's 2, because 5 squared is 25. See? Not so scary after all, right?
Okay, let's do another one. Keep the momentum going. What about log base 10 of 1,000? Again, just ask the question. 10 to what power is 1,000?
You got it. It's 3. 10 to the power of 3 is 1,000. You are totally getting the hang of this.
All right, time for a little curveball. What about a fraction? What is log base 2 of 1/2? The process is exactly the same. The question doesn't change one bit. 2 to what power gives me 1/2? Come on, think back to your exponent rules for this one.
It's -1. Remember how a negative exponent flips a number upside down? It creates the reciprocal. So 2 to the power of -1 is just 1/2, or 1/2.
And that right there reveals something super important. The answer to a logarithm, that exponent we're hunting for, can totally be a negative number.
Okay, so these examples have been great for doing in our heads. But let's be real, for the more complicated stuff, you're going to be reaching for a calculator. And lucky for us, it has a really helpful shortcut built right in.
This is a huge tip, so you're going to want to remember this one. If you look at your calculator and you see that log button, but there's no little base number written next to it, it's not a mistake. It has a secret identity. It's what we call the common log, and that always means it's a log with a base of 10. So your calculator basically has two main secret weapons for logs. There's the log button, which we just figured out is always base 10. And then there's the ln button. That stands for natural log, and it uses a really special base called e, which is about 2.718. And trust me, you'll see this ln button pop up everywhere in science and finance. It's crucial for things like calculating population growth or even radioactive decay.
Okay, so we've covered what a logarithm is, and we've even solved a few of the basic ones. So what's the big takeaway here? What's the point of all this?
Look, if you remember only one thing from this whole explainer, please let it be this. Logarithms are not some new, scary monster in the world of math. They are just exponents. Looked at from a different direction. Think of them as exponents in disguise. They're a tool we use for one thing, finding the missing exponent.
And that brings us full circle, right back to our original mystery. We now know what a logarithm is, but how do we actually use it to solve for x in that tricky problem, 2 to the power of x equals 30? You know, the one where the answer isn't a nice, clean whole number? Well, to do that, we need to unlock the powerful rules of logarithms. But that, my friends, is a story for our next explainer.